Hello friends, welcome to Maths Practice. In the previous video on triangles, we had discussed some important examples which were based on the basic proportionality theorem and the similarity criteria. In this video, we are going to discuss two very important proofs which are the proofs of the basic proportionality theorem or the Thales theorem and the Pythagoras theorem. Also, we are going to discuss some important examples from exam point of view. So please do subscribe to Maths Practice and watch the video till the end. The statement of the basic proportionality theorem or BPT, it is also called the Thales theorem because it is given by the famous mathematician Thales. The statement is, if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. That means from the diagram, suppose if you have triangle ABC and DE is parallel to BC such that DE intersects AB at D and AC at E, then the ratios AD upon DB will be equal to AE upon EC. Now we will discuss the proof of the basic proportionality theorem step by step. What is given to us is we have triangle ABC in which DE is parallel to BC such that DE intersects AB at D and AC at E. We have to prove that AD upon DB is same as AE upon EC. Now for the proof, we first join BE and CD. We join BE and CD. Also, we draw DM which is perpendicular to AC. And we draw EN which is perpendicular to AB. Now, we know that area of a triangle is equal to half base into altitude. So now, one by one, we will find the area of the following triangles. The area of triangle ADE is equal to half AD which is the base and EN which is the perpendicular. Similarly, area of triangle BDE. I have drawn the three triangles on the right hand side just to understand how we get the area. Area of triangle BDE is equal to half DB which is the base into EN. Now remember the perpendicular is outside the triangle. EN we have drawn perpendicular. So for area of triangle BDE it will be equal to half DB into EN. Similarly area of triangle ADE is equal to half into AE which is the base into DM which is the perpendicular. And area of triangle DEC is equal to half EC into again the perpendicular over here is DN. Now we have these four areas. So let us find the ratio of area of ADE upon BDE. It will be half of AD into EN upon half of DB into EN. So we get that equal, cancelling EN, we get equal to AD upon DB. Similarly, area of triangle ADE upon area of DEC is equal to AE upon EC. So now we have got two ratios. Let us continue with the proof. Now, triangle BDE and triangle DEC are on the same base DE and between the same parallels BC and DE. So from a result which we had seen in class 9, area of BDE will be equal to area of DEC because again they are between the same parallels and they have the same base. So hence we have three things. First is area of ADE upon area of BDE which is AD upon DB. Area of ADE upon area of DEC which is AE upon EC. But area of BDE and area of DEC are same. Hence, we have AD upon DB is same as AE upon EC. Hence the proof. Now we will discuss some examples important from exam point of view. Now these examples can be asked for 2 marks. First one, In triangle ABC, AD is perpendicular to BC such that AD square is equal to BD into CD. Prove that triangle ABC is right angled at A. Now what we are given is AD is perpendicular to BC and AD square is equal to BD into CD to prove that angle A is 90 degree. Now since it is given AD square is equal to BD into CD, bring one AD on the other side. So we get AD upon CD is equal to BD upon AD. Now if you observe, angle ADB and angle ADC both are 90 degree because AD is perpendicular. So now in triangles ADB and CDA, we have one angle which is same and the other two sides which are forming the angle are in proportion. So by SAS similarity criteria, triangle ADB is similar to triangle CDA. Now since both the triangles are similar, their corresponding angles will be same. So now angle DBA will be equal to angle DAC and angle BAD will be equal to angle ACD. Now we know that the sum of the three angles of a triangle is 180 degree, but angle A can be written as BAD plus CAD. So now we have BAD plus DAC plus ACD plus DBA is equal to 180 degree. Now instead of ACD, I can write BAD and instead of DBA, I can write DAC. So 2 into DAC plus 2 into BAD is 180 degree. Hence DAC plus BAD is 90 degree. But DAC plus BAD is nothing but angle BAC. Hence we have proved that angle BAC is a right angle. Next example. E is a point on the side AD produced of a parallelogram ABCD and BE intersects CD at F. Show that triangle ABE and triangle CFB are similar. Now, first of all, if you see in the figure, in triangle ABE and CFB, please take care of the correspondence between the angles for proving similarity. Now we know that opposite angles of a parallelogram are equal. So angle BAE and angle FCB are opposite, so they will be equal. Now AE is parallel to BC, that is given, and we know that alternate angles are equal. AE is parallel to BC, so AEB will be equal to CBF. Actually here we can say that BE is the transversal, so you know that alternate angles will be equal. So now in triangle ABE and CFB, we have two angles which are equal. So by AA similarity criteria, we can say that triangle ABE and triangle CFB are similar. Next example. Now this type of examples can be asked for 3 marks. In the given figure, if AB is parallel to DC, find the value of X. Now first of all, we will establish similarity between triangle BOA and triangle DOC. Angle AOB and angle DOC are equal because they are vertically opposite angles. Now since it is given AB is parallel to DC, AC is the transversal, so we have alternate interior angles to be equal. So angle OCD will be equal to angle OAB. So by AA similarity criteria, triangle BOA will be similar to triangle DOC. Since it is similar, the ratios BO upon DO is equal to AO upon CO. The ratio of sides will be equal. Now just putting the values, we have x minus 1 upon x minus 2 is equal to x plus 5 upon x plus 3. Solving, we get x is equal to 7. Next example. In the given figure, triangle ABC and triangle DEF are similar. Then find the lengths of each sides of each triangle. Now we can see that for both the triangles, it is given that triangle ABC and DEF are similar. Since they are similar, the ratio of the sides will be equal. So when you write the sides, take care of the correspondence between the triangles. AB upon DE is equal to AC upon DF will be equal to BC upon EF. Now putting the values, we get 2x minus 1 upon 18 is equal to 3x by 6x is equal to 2x plus 2 upon 3x plus 9. Solving the first two, we get x is equal to 5. Now putting the value of x as 5, we get AB 9, AC 15, BC 12, DE is equal to 18 given, DF is 30 and EF is 24. Only one thing should be taken care, that while you write the correspondence, the ratios, the sides should be maintained. The correspondence between the sides should be maintained. Next example. This type of examples can be asked for 4 marks. In a trapezium ABCD, AB is parallel to DC. Also DC is equal to 2AB. EF is parallel to AB where E and F lie on BC and AD respectively, such that BE upon EC is 3 by 4. Diagonal DB intersects EF at G. Prove that 7EF is equal to 10AB. Now first we list what is given to us. We are given AB is parallel to DC, EF is parallel to AB. Also DC is equal to 2AB and BE upon EC, this ratio is 3 by 4. Now in triangle BCD, we have GE is parallel to DC. Since GE is parallel to DC, we can consider DB as the transversal. So we know corresponding angles are equal. So angle BGE will be equal to angle BDC. Also angle GBE and angle DBC will be equal because they are the same angles. So by AA similarity criteria, triangle BGE will be similar to triangle BDC. Now since they are similar, the ratio of sides will be equal. Again I am saying take care while you write the ratio of the sides. BE upon BC is equal to BG upon BD is equal to GE upon DC. But BE upon EC is given 3 by 4. So BE upon BE plus EC will be 3 by 7. Hence since BE upon BE upon BC is 3 by 7, we have GE upon DC is also equal to 3 by 7. But DC is 2AB, so GE upon 2AB is 3 by 7. Hence first thing we have seen is GE is equal to 6 by 7 AB. Now like we have obtained GE, we will obtain FG. So triangle DFG and triangle DAB will also be similar, same way like we have proved previously by AA similarity criteria. Since DFG is similar to DAB, the sides DG upon DB will be equal to FG upon AB. But DG upon DB is 4 by 7. Why? Because it is given BE upon EC is 3 by 4, so EC upon B is 4 by 3. So DG upon GB will also be 4 by 3. So DG upon DB will be equal to 4 by 7. Since DG upon DB is 4 by 7, FG upon AB will also be equal to 4 by 7. So FG is equal to 4 by 7 AB. Now EF is FG plus GE, so that is equal to 3 by 7 AB plus 4 by 7 AB. So that is 10 by 7 AB. Hence we have shown that 7 EF is equal to 10 AB. Now in the revised syllabus, we do not have the theorems for areas of triangle, but previously there were some theorems which were for areas of triangle. Now we will just go through the statements, so in case if it is needed in any other exam, we can understand it. The statements of some theorems on triangles. Theorem 6.6 says that the ratio of the areas of two similar triangles is equal to the square of the ratio of their corresponding sides. Means if it is given triangles ABC and PQR are similar, then area of ABC upon area of PQR will be equal to the square of all the ratios of sides. Means AB upon PQ square is equal to BC upon QR square is equal to CA upon RP square. Now statement of theorem 6.7. If a perpendicular is drawn from the vertex of a right angle of a right triangle to the hypotenuse, then triangles on both sides of the perpendicular are similar to the whole triangle and to each other. Means you have triangle ABC which is right angled at B. BD is the perpendicular. Now here angle B is a right angle and AC is the hypotenuse. Then triangles ADB, BDC and ABC, all the three will be similar. The next is the Pythagoras theorem, which is very important and famous. It says that in a right angle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. If triangle ABC is a right angle triangle with right angle at B, then AB square plus BC square will be equal to AC square. Remember friends, this time the proof of Pythagoras theorem, in fact the Pythagoras theorem is omitted from the syllabus, but we will discuss the proof since it is a very important theorem. It is given that triangle ABC is a right angle triangle with angle B is equal to 90 degree. We draw BD which is perpendicular to AC. Now, by the previous theorem, theorem 6.7, since BD is perpendicular to AC, we have triangle ADB and triangle ABC both are similar. In fact, triangle ADB, triangle BDC and triangle ABC, all the three will be similar. Now, AD upon AB will be equal to AB upon AC. This gives AD into AC is equal to AB square. Again, by theorem 6.7, triangle BDC will be similar to triangle ABC. So, CD upon BC will be equal to BC upon AC. Hence, we have CD into AC will be equal to BC square. Now, if we add both of them, we get AD into AC plus CD into AC is AB square plus BC square. But now when you take out AC common, you have AC into AD plus CD, which is again AC. So hence we have proved that AC square is equal to AB square plus BC square. To understand the Pythagoras theorem, let's take a small example. A ladder is placed against a wall such that its foot is at a distance of 2.5 meter from the wall and its top reaches a window 6 meter above the ground. Find the length of the ladder. Now, suppose if AB is the ladder and CA is the wall, then we have to actually find the length of AB. It is given that BC is 2.5 and CA is 6. Now, by Pythagoras theorem, since angle C is a right angle, AB square will be equal to BC square plus AC square. Putting the values, we get AB square as 42.25, which is equal, the square root of which is equal to 6.5. Hence, we have got AB is equal to 6.5, or the length of the ladder is 6.5. Pythagoras theorem is in fact very much used in further studies. Friends, the converse of Pythagoras theorem is also true. Theorem 6.9, which is converse of Pythagoras theorem, says that in a triangle, if square of one side is equal to the sum of the squares of the other two sides, then the angle opposite to the first side is a right angle. Means if in a triangle ABC, AB square plus BC square is equal to AC square, then angle B will be a right angle. We will not be proving this theorem since, as I told, in the recent syllabus, Pythagoras theorem is omitted. Some assignment examples. Example 1, in given triangle PQR, if QPR is 90 degree, PQ is 24 and QR is 26 centimeter. In triangle PKR, PKR is 90 degree and KR is 8 centimeter, then find PK. You are given the diagram. You can use the Pythagoras theorem and the answer is PK is 6 centimeter. Next example, a vertical stick of length 6 meter casts a shadow 4 meter long on the ground, and at the same time a tower also casts a shadow of 28 meter long. Find the height of the tower. Here you will get two triangles and you will be able to establish a similarity between them. So the answer would be the height of the tower would be 42 meters. Example 3. Triangle ABC is an isosceles triangle where AB is equal to AC. E is a point on the side CB produced such that FE is perpendicular to AC. If AD is perpendicular to CB, prove that AB into EF is equal to AD into EC. Now here, when you draw the diagram, you will be able to use the AA similarity criterion to show that triangle ADB is similar to triangle EFC. And on the basis of that, you will be able to prove AB into EF is equal to AD into EC. Friends, in this video, we have seen many examples which can be asked for 2, 3 or 4 marks. In the previous video also we had seen some important examples based on the basic proportionality theorem. The proof of the basic proportionality theorem or the Thales theorem is very important, and also the examples. We have the BPT and its examples and the similarity of triangles and examples based on that. This year the Pythagoras theorem and areas of similar triangle has been omitted. So we have not discussed more examples based on that. Please do like and share the video and subscribe to my channel Maths Practice for many more such videos. Thank you.